Okay, hello. I am Choroba from Prague. I work at Good Data, and I'm going to tell you about schema updates and how to make them zero downtime. So first, the plan of the talk. I'll start with a story. Then I'll describe problems of schema updates. I'll define downtime and what I mean by zero downtime. And I'll show a more complex example to illustrate the solution and the details of it. So a story. There was a recent lightning talk by Kivanch about the pull request club. So this is about the pull request club, which was a successor to the CPAN pull request challenge. And when I joined it in the very first month, I was assigned the pull request challenge, the app itself. And there were several open issues there. And I selected the one that concerned this page, which lists your GitHub repositories, and you can select which of them to offer to other participants of the challenge so they can open pull request against them. And this page, this is the issue. So the problem was that this page talked to GitHub every time you opened it. And when you did that, it took several seconds, even for me, and I only have like 20 repositories. So for people having hundreds of repositories, it probably took even longer. So there was an issue to limit this to only talking to GitHub once a day and to cache the response and to add a pull or refresh button. If you add a new repository, you want to immediately share it with other people and not wait one more day to appear in the list. So I looked into the implementation of the application of the pull request club application, and it was written in Catalyst, and for the database it used DBIX class core. And you can see that this is the user table, and it contains various columns. And we want to add the time of the last fetch from GitHub there to this table. So the patch is shown here. It's pretty easy. The first block shows the last repo sync, which is the time of the last sync with GitHub. And underneath, you can see in the fetch repos subroutine, we skip fetching the repos if the time is not 1 day or more. And what's also important at the end, we have to, after we've actually fetched the repos, we have to update the last time in the database. I also had to change the SQL command itself. I'm not sure whether it's needed when you use DBIX. I think it's like doing the same thing twice, but maybe it's needed. I don't know. So the problem is that creating a new table with the column is okay, but it's not what we need for the already running app, because it runs. We don't want to create a new table. We want to change the existing one. We want to alter the table. So we need this SQL command, in fact, but there was no place to insert it in. So I put it into the commit message. And I also implemented the reload button, but it's not important for this talk. So this is something that happens quite often if you work with databases. So there exist tools to help you with that. One example is Squitch. It's written in Perl. It would store the initial state of the database and then a sequence of these alter tables or other statements that must run to like bring the app up to date. And you can also like have different databases in different phases, and it knows what alter tables to run and what to skip and so on. So it helps a lot. And in fact, Purikas Club was migrated to it 4 commits later. I have a question here for Squitch users, but it's not so important. So if someone knows, please let me know later. That whether you really keep the initial state forever and just make the list of alter tables and SQL statements longer and longer, or whether it's possible, or whether there is tooling for saying, okay, the actual state will be the initial one, and I'll like throw away all the alter tables and we'll run again from. Okay, I see the message. Thank you. And there are probably many more similar tools. I just know this one. So what happens when we alter a table while the app is running? So there are many possibilities. Some of them are bad. So for example, the application might crash because the front end is not ready for what's coming from the back end, or vice versa. But there are even worse scenarios, like we might corrupt the database, or we might some data might get lost without notice, so we don't know what was in fact lost. And there's the happy scenario as well, that everything just works. Sometimes it happens. So and this is the general problem. There might be different changes than alter table. You might like assign a new permissions to users or something. And in fact, database doesn't have to be involved at all. So the easiest solution is downtime, which means we want the old and new code to never meet live. So we just switch everything off. And then we apply the changes, and then when we switch everything on again, everything runs the new code and everything is okay. But it's not always possible to switch off an application. There are services that can't be switched off because they are critical, or because the customer just thinks they are critical. Think of some hospital software or something. So there is a way how to do it zero downtime, which means without turning the application off, in fact. So there are some conditions we must stick to in order to be able to do that. So one of them is that all changes must be backward compatible. You can also make all changes forward compatible, but it's a bit harder to achieve. And you proceed in steps, where by steps I mean releases of new code. So what are the steps? So the first step is the code that we release will accept data conforming to both the old and new schema. We don't have any data conforming to the new schema, but the code is already able to handle it. And then once we are sure this code is everywhere, there is no old code anywhere anymore, we can start producing. So this is the second release that releases code that really uses the new schema. And any other part of the application already knows how to handle that, so there is no problem. And then there is the third step, which is a cleanup. We just remove support for the old schema. And this is a bit problematic again, because we must be again 100% sure that there's no instance of the old code running. So for example, if you have a session that lasts for 1 day, there can be a user who keeps a page opened and he clicks on save the next day. So you have to wait really the 24 hours or whatever your session, whatever the time of the session is, before removing the code, so you don't break the application for them. So I'll be talking about this from the point of view of a contract between internal components, but changing a public API is quite similar, but it's usually more explicit. We usually use versioning. There is like some kind of a deprecation process, which means we announce to our customers, we are going to change the API. You have, I don't know, 3 months to adjust. The availability is probably specified in the contract. So we have to, we can't use the downtime as we would like, because it might break the contract. And it involves a lot of communication, because customers sometimes will say, well, okay, just keep it a bit longer for us. We don't have time to fix it now, and we'll pay you some money to keep it the old way and stuff like that. So now I'll show you a more complex case, which is what we do at Good Data. So we store our customers' data, and they have, so it's this database on the top, stores the data, and we store the schema of the data in another database. It's this metadata storage. And we have several different virtual machines, all of them with different purposes and with different parts of the code available. And what will be important here is the metadata object, which is basically a Perl object that corresponds to the schema stored in the metadata storage. We also have backups, which are just some kind of files somewhere. And we have a validator, which is a code responsible for validating the objects coming from outside. Each update of schema, or of metadata as we call it, has 3 components. One is the code change, which changes the code in the metadata object. There is something called offline update, which is code which updates the metadata backup, because we store the backups, and when you want to restore a backup from, like, I don't know, 3 months ago, you can't just take it and load it into the database, because the schema might have changed in between. So you have to upgrade the metadata in the backup. So that's the offline update. And then there is live update, which updates the actual data in the metadata storage. And it in the simple cases, it just runs the offline update on the stored structures in the database. So they can be quite similar, these two. Okay, so in this case, when we want to, for example, add a new column or do some other schema change, we start with actual change in the data database. Here, the backward compatibility is crucial, because we change the schema, but everything works as it worked before. No one notices the change. Okay, so that's the first release. Another one, code change and release, is we start accepting the metadata conforming to the new schema in the object, but still no one produces these objects, or these structures. So it's okay for us. Nothing happens. Then we have to update the validator to treat the new schema as valid. This is needed for integration tests of the next step to pass. because in the next step, we'll start producing the metadata conforming to the new schema, actually. So in the metadata storage, we now have a mix of both old and new objects conforming to the old and the new schema. And once we are sure that this code is everywhere, we can run the live update, which updates all the remaining data we haven't touched yet to the new schema in the metadata storage. This step doesn't require a release. You just run it. And the last step is a cleanup, which removes the support for the old schema. Okay, so how is this done? The metadata object is a Moose class, and among other things, it always has these two methods to serialize and deserialize the structure. So what we did, we created a role that you apply to the metadata object, and you specify, instead of the serialize and deserialize methods, you specify these four, where two of them are the original ones and two of them are the new ones, which handle the old and the new schema. Usually they have like a common code that doesn't change at all, and you just change one small thing somewhere. But the important thing is that we have both these in the first phase already. And then the second phase, which starts producing the changed data, in fact, or metadata, you just change this one digit, and that's all. So how does the role look like? So in phase one, you can see that the role requires these four methods, and somehow provides the serialize and deserialize methods that were there all originally by deciding which one to call. There is also this is updated. It's a method that tells the object whether the structure retrieved from the database is using the old or the new schema. The easiest way how to implement it is to just use versions, but we originally used something else. It's not so important. And we have this should use updated, which defaults to 0, which means if we serialize the object, if we didn't update it, the default is used. So we use the original serialization. But if we should use updated object, we can store the updated object. This doesn't happen in the phase one, but we are ready for that. And when deserializing the object, we check the structure, whether it's in the old or the new schema. If it's the new, we set the object to use the updated schema, and again, use the correct method to deserialize the structure or to inflate the object. And the second role is even simpler. Somehow, one would think that we will take this and put one here, which we originally did, but then it's easier to just like omit it completely, because we always use the updated method here. And deserialization is similar to the old one. We use the method appropriate for the structure we are deserializing, which means we need 5 releases to deliver a single schema change, but everything happens while the application is running, so customers don't notice anything. And we have a process called feature hotfix, which makes this possible. And it usually takes a day to do it because of test suites and integration tests and blah, blah. So in fact, it takes about a week to deliver such a change. Okay, that's it. The slides are not there yet, but I'll try to make them appear at this URL in several minutes. Thank you.